Hello Houston, I am Jason Hammond, the Science Outreach Educator and Life Science Educator here at the Children's Museum Houston, and today I'm going to be doing a really fun experiment called Magnetic Money, sponsored by Bank of America. And I'm going to be using this dollar bill to show you what's going to happen, but I am not going to do it right here in front of the bank. We're going to head on over to our science station. And just as a caution, science can be fun, but it can also be dangerous, so please have a responsible adult nearby when performing these experiments. Okay everybody, here we are at our science station where I'm going to perform this magnetic money experiment. The first thing I want to do though is talk to you a little bit about the very special magnet I'm going to use. I have this magnet wand here and I'm going to slide off this magnet right here. This is a very strong magnet called a neodymium magnet. You have to use this type of magnet when you do this experiment because if you use like a regular ceramic magnet that you say have on your refrigerator home holding up a piece of paper, it won't be strong enough to perform what you want to perform in this experiment. The reason why I use this magnetic wand is because it makes it easier for me to move around the neodymium magnet when I'm performing the part of the experiment that's pretty exciting to see. So I just stick this on here like that and you can see that it sticks. Now remember, magnetism in this sense, when we're talking about metals and whatnot, they actually either stick to each other or they propel each other. And if you look here, when I try to do it right from here, it's actually moving it around because it doesn't want to stick there. All right, it's actually a repulsive effect here, but when I turn it around, it immediately sticks on. You got to be careful with neodymium magnets as well, because if you put two of them together, they'll attract so violently, they'll crack each other. So that's another reason I'm also using this kind of magnet wand so it doesn't crack it. Now, in nature, when it comes to say like the periodic table of elements, only 3 metals are purely magnetic, and they're all right next to each other on the periodic table, number 26, number 27, and number 28. That is iron, cobalt, and nickel. So if you were to make it a hypothesis, what would you say this magnet is made out of? Well, neodymium is also on the periodic table. It's number 60. It's further down the way. But you have to have some magnetic metals in here, some rare earth metals. So you're also going to have some iron in there, and basically it's nickel plated. So you've got 2 of the magnetic metals that are natural within this magnet. The neodymium just makes it that much stronger. Okay, so what we're basically going to do is I'm going to take this dollar bill here, and you see this blender next to me? I am actually going to put the dollar bill in the blender and I'm going to blend it up using this water as well. And the reason why I'm going to do that is I want to make a slurry like this. I've already done $1 before, so I'm going to sacrifice $2 for this experiment. But I always like to have one ready just in case anything goes weird, and I know that this one's working. So just give me a moment. We're going to grind this dollar bill up, but it takes a good amount of time. It's going to take about 3 minutes to do that. So what I'm going to do is I'm going to dump inside this blender my 2 cups of water. So you're going to need a measuring cup as well. And then I'm going to stick my dollar bill in there. Okay, so you can see my dollar bill is floating in there in the water, but in a moment it's going to be into millions and millions of little shreds. I'm going to put it on high, and we're going to blend it for about 3 minutes. So when you do this at home, remember to blend your dollar bill at least 3 minutes. 5 is even better, but we'll do it for like 3. Success! Okay, so now you can see I have completely shredded up my dollar bill. Some of you might be wondering with this experiment, what if I use a $5 bill or a $10 bill or a $20 bill? Will I be able to get more of the metal experiment out of it? No, it's the same amount of metal in each bill, so we'll always use a dollar bill. Now, once you get this sort of what we call slurry, this greenish slurry, you're going to want to put it into a bag. So you're going to take the top off and very carefully remove that, set it down until you're ready, and then pour. All right, and then you are done with the blender. Now, obviously, you should close the bag when you're done. You don't want anything getting out. Try to get as much air out of it as well. Okay, now we have 2 bags of slurry. We will try them both. Now this is called metallic money. So the reason why we did what we did is because there is a trace amount of metal inside all denominations of money, whether it's a dollar bill or a $100 bill. The reason why the federal government who prints our money puts that metal in is to reduce what we call counterfeit. We don't want people making fake dollar bills and being able to get stuff using those fake dollar bills. So if you were to put a dollar bill into a vending machine that had no metal traces in it, the vending machine would not accept it. And in some cases, the vending machine will set an alarm off and people will know there's a fake dollar bill inside. So run. Now, you can't see the metal, but you can extract the metal from this slurry. And the way you do that is using your neodymium magnet. So this is what I'm going to do. I'm going to put this on the palm of my hand, right? I'm going to put the bag on top, okay? And I'm going to go like this. Just give it a little shake. And what that should do is it should bring all the iron shavings, the little pieces of iron inside the dollar bill, over to the magnet. And I can check that and it's working, all right? So then you very carefully move your hand over like this, remove your hand, and then very slowly remove the magnet, and you can see the metal inside. And then you can move the metal around. You see me moving it around? So when you visit the museum, the Children's Museum of Houston, we do have a magnet bridge right here where you can see how ceramic magnets work, holding on to these little metal rings right here, probably made of iron, possibly nickel in there. But you can also see how this one really sticks on there pretty good. You actually have to slide it off, you can't pull it off, because once again, the neodymium magnets are so much stronger. So when you come back and visit us, please come by the magnetic bridge here and learn more about magnets. Okay, so now that you can see with this fun experiment, you're able to extract little iron fillings from a dollar bill. Now, let's be smart about this. Don't use dollar bill after dollar bill after dollar bill after dollar bill. $1 bill is enough, you know, it's all good. If you're gonna continue doing this experiment over and over and over again, you're gonna start to want to borrow dollar bills from your friends and family, so don't use all your money up in the experiment. I also wanna mention the neodymium magnets. They're not necessarily hard to find, but they're not really easy to find either. It's best if you ask someone for a neodymium magnet. So if you're at a hardware store like Home Depot, just go up to someone that works there and say, hey, where are your neodymium magnets? And they'll know exactly where to find them. They are much different than ceramic magnets like I mentioned before, so they're a little bit more difficult to find. So this is Jason Hammond saying goodbye from now from Children's Museum Houston. Hope to see you soon.